Hello. Today we're going to look at tides recorded in Newport, Rhode Island during the month of June of 2016. So what we're looking at here is a graph of the water height, which is plotted on the y-axis in units of feet, versus time in hours during the month of June. So we have 720 hours in the month of June, and we can see the water height fluctuate. Now these local maximums in water height are high tides and the minimums are low tides. And so you can see the tides cycling throughout the course of a month. Now if we focus in, say on one day, 24 hours, we can see in Newport, Rhode Island, we have 1, 2 low tides and 1, 2 high tides. And the low tides and the high tides are approximately the same height. So the low tides are the same, just at zero, a little bit above zero mean water height, and the high tides are right around 4 feet. Okay, so this would be considered a semi-diurnal tide, where there's 2 low tides and 2 high tides of similar height in one lunar day. Remember, a lunar day is actually 24 hours and 50 minutes. So we'd have to change this a little bit. We need to actually get one full tide. I almost put 25 hours in. But, so let's see, 1 day's worth of tidal record. Let's look at 2 days worth of tidal record. So we see 1, 2, 3, 4 low tides, 1, 2, 3, 4 high tides, as we would expect. You can see it looks like this second, so the first high tide is a little lower than the second. You can see that in the first day. You can see it in the second day here. But the low tides are pretty consistent. But that still is a semi-diurnal tide. If it's a mixed tide, the difference in the 2 high tides is fairly dramatic, and the difference in the 2 low tides is fairly dramatic too. And so we can see the periodicity of the tides coming in and going out throughout the course of a lunar day. Now these tides look fairly consistent on a short time scale, but if we look at the entire month, we see that there's variability in the tides. So the high tides are higher, the low tides are lower at certain times of the month. Other times of the month, the high tides are lower and the low tides are higher. And so what explains this? And so this is the difference between the high tide and the low tide is known as the tidal range. So you have a large tidal range right here and a very small tidal range right here. So what is the reason behind this? Well, it has to do with the position of the moon and the earth and the sun. So if we scroll up, the same data here, but instead of plotted against time measured in hours, we have it in time measured in weeks. Okay, so we have 4 and change weeks in the month of June, and we can see that it's early in June. In the first week, we have this very large tidal range. Okay, and then near the end of the second week and near the beginning of the third week, we have this smallest tidal range. And plotted below it is the percent of the moon that's visible during about the course of June. Now this is relevant because this tells us what lunar phase existed at this time. So if 0% of the moon is visible, that means that we're in a new moon phase and that the moon is positioned directly between the Earth and the Sun. So this would be a new moon right here, where 0% of the moon is visible. Whenever 100% of the moon is visible, that's called a full moon phase. That is when the moon is in line with the Earth and the Sun, but so the Earth is directly in between the moon and the Sun. So a new moon, the moon is directly between the Earth and the Sun, in a full moon, the Earth is directly between the moon and the sun. And it's in the new and full moon phases that the lunar tides constructively interfere with the solar tides. And that constructive interference results in a larger tidal range. And we can see that this large tidal range right here coincides with this new moon phase, and this larger tidal range over here coincides with this full moon phase. And so the opposite of the full and new moon phases is whenever the moon is not in line with the Earth and the sun. In fact, if you look at the line that connects the moon to the Earth and Earth to the sun, it makes a 90-degree angle. That is the first and third quarter lunar phases. And during the first and third quarter lunar phases, only half of the sun, half of the moon is visible. So around 50% is visible. So this is going to be, this is the new moon. This is the first quarter. And see, it's right around this first quarter that we have the lower tides. Now these are called
5:30.
Excuse me. These are called neap tides. These diminished tidal range because the lunar tides are destructively interfering with the solar tides. So they're working against each other, creating this diminished tidal range. Unlike the spring tides over here, where the lunar and solar tides are constructively interfering, adding to one another, neap tides, the lunar and solar tides are destructively interfering, taking away from one another. Then over here you have constructive interference again with the full moon, creating spring tides. And the neap tide over here, it's hard to see, it's not really visible. This is a very clear neap tide right here, and a very clear spring tide right here. And since the lunar phase is roughly 4 weeks, the new moon, the difference between a new moon and a full moon is roughly 2 weeks. So the periodicity between spring tides is roughly every 2 weeks you have a spring tide, and every 2 weeks you have a neap tide. Okay, and so that explains this variability in the tidal range in the tides observed here. So that is all for tides. Thank you very much.